Great, great. Glad you're coming.
So Laura was in like.
Okay, all right. So you're here to make sure he doesn't slip up.
No,
Yeah.
you can borrow.
Oh, okay. All right. I'm gonna get started. We have an interesting colloquium today. We're gonna talk about death.
Yeah.
Sorry, don't want to start on too somber. Yeah, it's really a pleasure to have Álvarez from TDS here to talk about stuff going on in SHC related to being able to deal with EHR data in a more intelligent way.
In one way. Let's see. All right. Thank you, everyone, for being here. My name is Álvaro Andrés Álvarez Peralta. I work as a business system administrator in the STAR Data Science team, in the technology and digital solution at Stanford. And we are going to talk about today about an exploration we keep doing about improving the death data in our Stanford databases. Before we start, I want to give a little bit introduction about myself. I am a computer science engineer. I'm originally from Colombia, and I have been working at Stanford since 2016, initially in prospective data capture and research with RedCap, if you're familiar with that. And more recently, I moved to the retrospective side when I'm working with Priya's data science team, focusing on OMOP and in improving the data that we have already collected. On the right side of the screen, you can see my family, my daughter, and my wife, and my newborn, my baby Arturo, which is a month old.
You're awake. Congratulations.
So as you can see, that's how I work most of the days. I have one hand and a pacifier and fine. Interesting experience. All right. A little bit more about Colombia. I always want to talk about the country. I don't know what you hear about, but I want to tell you very nice things about the country. So I don't know if you know Gabriel Garcia Marquez. He's a Nobel Prize, Literature Nobel Prize in 1982. One of his most famous books is 100 Years of Solitude. It's one of the fathers of the magic realism, which is it's a very nice way to tell stories that sometimes are not that nice. And you can see that actually in the last year's movie Encanto. I don't know if you saw it. As basically a representation of Colombia and the way many things the way that we see the world and all the diversity we have. We also have famous artists like Shakira. Sure you hear about her. And the 2010 MVP for the World Series from the San Francisco Giants was Edgar Renteria, which is Colombian also. If you like sports, we also have the winner of the Tour de France 2019 and Giro d'Italia 2021. And of course, we have to talk about coffee. Coffee is, we are known for coffee, and I just want to finish this part with a short story about the coffee in Colombia. In the left side of the screen, you can see a big machine that is picking up coffee beans, and that's the way that most of the countries around the world do that process. It's a big field where there's a big machine picking everything that it can do. And as you can see, the beans that it's picking up, some are really red, some are green, some are dark. So there's a lot of variety. In the right side of the screen, you can see the mountains in Colombia. Well, the mountains are beautiful, but also they make it very hard to have a machine to pick everything. So we have to go and manually pick the beans. And that's why Colombia has the most quality coffee in the world. So just a quick story about that. Before we start, well, about that. All right, so let's start with this.
I have a
So-
question about Colombia.
Sure.
Which is the nicer coast, the Pacific or the Atlantic coast?
Oh, I love both. The most commercial, the most touristic is the Atlantic coast, where you have Cartagena and the wall. How do you say that? Amurallada. It's a castle where this people from Spain built like a fort, and it's now is very nice. I like the Pacific. I'm from the Pacific side.
Yeah.
I came to the Pacific and I like the Pacific, so I'm here now. All right. So, any other questions about Colombia? All right. So, why is this project needed? Patients come to our hospitals, and in the best scenario, once we treat them, they go home and they are very happy after that. In some cases, they die. If they die, we have good data. But when they leave the hospital and they are fine, we lost track about what can happen to them. So what can we do with that data? Can we recover? Can we do something with that? Can we learn from anything else about that? So having good mortality metrics are essential, and they're very useful for clinical trials, for any observational studies. Also for national rankings and numbers at the hospital, like that. How can improve that accuracy? So what we think is, okay, there are external data sources that we can try to find and see if we can, with those external data sources and or Stanford data, if we can do something to improve what we have. So there are multiple data sources. This is just a list of 4 that we have access or we know about. Of course, we have our Stanford Hospital, adults and children. And of course, we have the data we capture here. We also have the NDI. The problem with this one, we just were discussing that, is that it's per project access, and it's very expensive. But it's known as the best data source and the more reliable. We also have we do have access to the Social Security Administration, LADMF. Well, I'm from Colombia, so I have problems with English, but I made that point up.
Everybody could have a problem with that.
All right, so that we have access, and then that's the database we are going to use for this exploration. We are also working in getting the California public use that data, which is more focused in California and could give us better data. But that's a working process. We don't have access yet. We have to figure out many things about it.
Can I just, do you mind if I interrupt? Is the sort of goal, would the goal be to, talking to a Finnish colleague, and they have their medical care system that every year there's just an update that happens with the death registry so that you annually know whether or not your patient or an individual is dead or alive. Is this something that we could work towards, or is that completely?
So you're saying, can we link the Medicare, Medicaid data with our data? Is that what you're asking?
Yeah, basically, if we have an individual that we're following across time and suddenly we don't see them anymore, is it because they're fine and they just haven't shown up, or is it because they're dead? To me, I mean, you have a certain risk of death annually based on your age, right? So there's a certain probability of being dead, but then to actually know that you're dead is.
That's a good point, and that has to do also with the approach that we took here, and I'm going to talk about a little bit of that in a moment. Because yeah, you can imagine or the probability of, but are you sure? You may not be sure. We just guessing. So let's see. So we're going to work with the Social Security Administration database, which is not the best data set, but it's the one we have. And we have a good amount of data there. So to understand a little bit of what type of data we're working here is the structured data. We're going to use our Stanford Healthcare Clarity database, which has all the information from patients, social security, first name, last name, middle name, birth name. Sometimes that date and well, more information, but we have a restriction about the Social Security Administration that data. We just have this list of variables: social security, first name, last name, middle name, birth name, and death date. So, okay, with that, what can we do? How can we think in a way to match these two databases? By the way, it's not a simple join. At this point, you will know that. And improve our data. All right. To do this, there are two main paths. You can go in a deterministic path where you try to, which is what we are doing here, where we are going to use the exact match of combination of variables and see what works better. Or you can go with the probabilistic method. Well, I'm sure here there's many people experts on probabilistic methods, where you can go from just simple statistics to machine learning and beyond. But that's a cool thing. Let's see that maybe that works with. Okay, so what we are going to do here, or what we did, is to create something we call tokens for this context. A token is a combination of the variables. So think about, we have social security, last name, first name, and birth date. That's going to be one token. And social security birth date, that's going to be a second token. And then you can start thinking in all the possible combinations. Of course, that can be a lot of combinations. So we are trying to, in a methodic way, try to analyze the most likely good tokens instead of analyze everything, every possible combination. In this case, we have a limit of variables, but what if we have more variables? That would be. And then the way that we're going to do it is by thinking in the completeness, distinctiveness, and validity of each variable and each token. And I'm going to explain a little bit more about what that means. And finally, we want to validate the best way we can is with our own data. So we have that data from our patient at Stanford. So we want to validate this method with our that data and see what the results are. If which combination is the best, well, we don't know. That's actually out of the scope. But we are going to show you what we found when we did the combination. Speaking of completeness, distinctiveness, and validity. So completeness is referring to the fact that we have some data for a specific column. For name, in this case, we have data for 5 rows, which means we have all the information complete. Distinctiveness, meaning how unique is each one of the columns, each one of the variables. The way that you can think this in databases is select distinct from a column if you are familiar with SQL. So in this case, we're going to say John, Arthur, Anna, they are different. Whatever this is also different, but John is again, it's repeated, so is distinctiveness is 4. And validity, now we think, okay, what the data that we are collecting or we have in this column is valid or not. So we can see that for name, well, this can, I mean, there's names with that are numbers, but in this scenario, we're going to say that's not likely a name. So we are not going to take it. We're going to say that it's invalid.
This slide reminds me, I had a friend whose last name was Null, and when databases came out, when databases came out, she would break them.
That's super funny. Well, some things can happen. All right, so same example with the date of birth. Any question about it? Is pretty much. So based on that,
distinctiveness, sorry, this is, so these are, distinctiveness is comparison to something else, right? So you can't talk about the distinctness of a single entry, can you?
So what I'm doing here, what we're doing here is select how unique is for the column. So John is not very unique because it's twice in the same column, right? So we count John as 1 instead of 2.
I'm sorry, is this multiple records here? Oh, I see. Okay, got it. Thank you. Yes.
I got a question. Sure. So in some of these things, let's say JHON, a person had a name with a dash on it, and clearly that was a mistake. The dash shouldn't be there. Do you do some kind of fuzzy matching or something like that?
We'll show you what we do.
Okay.
So yeah, there's actually here's we need to clean the data, and we want to avoid things like that. When it's possible, we try to recognize. But this specifically for this scenario, these were the steps we did to do the normalization. When we talk about normalization, is hey, we have 2 different data sources, and who knows who entered the data in those 2 data sources. So we want to go to a common format so we can compare them. So what we do is we exclude some of the dates before 1850. We exclude numbers as names. I think we don't have any null last name or something like that.
How would you know?
And I'm going to double check. And exclude, and this one is important, invalid social security numbers. Also, we remove unwanted characters. So in this process, we may put, if we have a hyphen name, last name, and in the other database is together, we're going to remove every hyphen, which will make just an entire word, one word. So it's not a perfect thing. We just do that for everything, but that's our approach to try to clean as much as we can. We do everything, we truncate, we do uppercase, and then we create a tokenization. And again, the tokenization is basically a concatenation of the variables in a single string, so we can compare one string in one database with one string in another. And this one is also important. We only create tokens when all the variables are available. Because if we don't do that, then it's going to be very messy. We're not going to know.
So what
Okay, as a
percent-
result,
what percentage does that knock out?
I'm going to.
Okay.
Does everybody have I don't have a middle name. Like, do most people have a middle name?
I'm going to see that. That's just a great question. That means that I'm going the story the right way. Great. So as a result of this process, we are going to create 2 new databases with all the tokens and the normalization. And now let's answer those questions. For the someone.
Yeah, this may be my ignorance, but how do you know an invalid social security number? What is the way?
That's great. I have a slide for that. Okay, this is interesting. So let's talk about the external data source. When we analyze the variables that we got, we have 102 million records. And then what we learn is the social security number. This can be intuition. Well, it's unique for each one. And then we have all the records, 100% of the records. Nothing is distinct. There's no new values and there's no invalid. So it's great. So the social security number, as expected, as was initially we may think, is a great primary key to join the databases.
So the number of records is not number of patients, is it?
The number of records is the number of people in the dead people in the Social Security Administration.
You could be there. Incorrect.
So remember, like, we're looking at 2 separate databases, right? We're gonna look at ours and we're gonna look at Social Security. So right now, we're just looking at the Social Security.
And the social security, they do know that you're dead.
They have various ways of confirming that they're dead. There is an even better Social Security data set, but which actually gets updated data from each of the states. but it's really hard to get access to that. Even for this, like we are a subscriber, so we do get monthly updates for this, but this is supposed to be pretty good, yes.
All right, so when we analyze the last name, of course, we can think, okay, last names are repeated all the time, so they are not very distinct. It's just 2% of the data is unique. Name suffix like junior, well, that's the worst, as you can imagine. First name, important thing to understand or to see here is the birth date is also not unique. I'm just mentioning this because many cases people use date of birth and social security to try to find data. We'll see what happens. Okay, and what happened with all data, and here's where we start finding some interesting things. The way that our data, we have our own unique identifiers for the patients, which is the PAD ID. We have 4.5 million. And for the PAD ID, okay, everything is unique. But when we see the social security number, well, here's where weird things start happening. We don't have for all the people the social security numbers. And not all the social securities are unique in our data. And there's null values, of course, and there's also invalid. So, okay, so let's explore and talk a little bit just before we move. The last name has a 50% of distinctiveness. So that's important because that's make the better second candidate to join. So let's explore a little bit about the social security data in our database. So we learned that we just have 47% of valid social security numbers in our database. We have 15% null and invalid 36%. And in case you're wondering what is an invalid social security number, there's a set of rules that the Social Security Administration has. There's some numbers that are never going to happen. And we can add that in all filters to make sure that are valid or not. Just out of curiosity, we also did the same test with the LPCH Children's Hospital. And of course, the numbers are worse because a newborn doesn't have a social security number. So that's why you can see here the 1.5 million records. We just can use 14% and make sure that that's good social security numbers too.
So you've got these 4.5 million records. Over what time frame is this then? Just
It's since 2008.
2008, and then the 102 million from the SSA.
So that's the social security, yeah.
And
So
that's the same sort of time frame, or?
that's a good question. I actually need to look into that. I'm not sure since when that data is.
I don't know.
but yeah.
All right, so a little bit more in detail about the invalid social security numbers. So just so you have a better idea what are we dealing here. It's a lot of 99999 numbers, 88880000. But there's a lot of other combinations that at the end they add up to create this big monster we have here.
I think people will be more creative if they're gonna make stuff up.
Not if it gets you through the form.
Yeah. So, okay, so that's the challenge. Now, yeah, we know that the social security, when it's clean, when it's good, we can have a good match. But then we're losing a lot of data. Half of the data we have in our database, we cannot even test if we just do a normal match, like many people does with social security plus last name or social security plus date of birth. That's going to give you something, but we're going to lose a lot too. So we start building our tokens with that in mind. And what we learned from this previous revision is that our social security number, when it's available, is a great candidate. So we start building our tokens in a methodic way using the social security as our first element of the token. But the second one was even it was very far, the second in distinctiveness was the last name. So we took the last name and create a list of tokens based on last name to see what may happen. And just because we had that already, we decided to test the Soundex algorithm, which is basically, is already built in, it's just applied to names and the phonetic sound of the names. If you have John and Juan, something like that, they can go, the algorithm translate them to the same code. So we can think that even if it was a spelling problem or something typo, they will match. But this is a nice thing to do, but it's not perfect. It just works with English, with the English pronunciation. And in the Bay Area, well, we have a lot of diversity, which makes this not as effective as we can want. And just for comparison, just to make sure that we were doing the right things and we didn't have any crazy number, we also added single variables. Sure.
I was speaking up for you.
Oh, thank you. I had a question about the social security numbers. Are those because like they were written on paper or like they were entered on the computer and it didn't catch that? Like especially the X's, because social securities numbers, right? So I was wondering like why that is, or like maybe patients didn't have social security numbers.
Okay,
or,
okay.
like, yeah.
So no, I'm sorry for the X. The X means it doesn't matter what number is here, it should never start with a 9. So basically this is 3,000 social security numbers that are starting with 9, which is not valid. And so, yeah, and the same with the other one. You never have to be having 0, 0 as the middle. And then the rest of the numbers doesn't matter because you never have, same thing with the rest. Because, yeah, it's a matching pattern.
To that point, do you have any insight into the provenance of the social security numbers? Like, are these doctor ordered or doctor entered, patient entered, taken from a form, entered online? Like, do you have a sense of?
Unlikely to be doctor entered, more likely to be patient entered and or taken from a form. It's like, this is whatever's recorded at the hospital. So typically, I think when you come to see a doctor.
It's also important to think that the social security number is less and less enforced every time in the hospital. I mean, if you have an emergency, that's not relevant. And sometimes people doesn't know. There's also some stories I hear about, someone in the team told me that in the past, the social security number was the only, in a family, just the husband has a social security number. And then if the wife needed attention, she had to use the husband's social security number. So many circumstances, many things can happen around that.
I also have a question on social security number, but how often do you see that some people are able to bypass the rule-based filter that you have and still come up with an invalid social security number that you may not be able to identify, but you may have came across a few instances when you're analyzing the data? Is there other instances like that? Yeah, so basically you have this if statements, right? 4, 5 if statement that you check for the invalid social security number. Has there been instances that a social security number has bypassed all that filter, passed your filter, but still was invalid? And how common is that? And how would you even check for that?
So I'm sure that since it's a regular expression actually, but I'm sure it could be not perfect at all. But what we did here is we analyzed data post we had a specific group of data that we were analyzing. So for that data, we assume that what we capture in that is the right.
Okay.
But yeah, it will be interesting to have like a pipeline process that is evaluating all the time. But yeah, we don't have that in place. So I don't know.
One more question just on names, like Jorge Álvarez de los Santos Peña. What counts as the middle name in that case?
It depends on, since this is a structured data, we just have to trust in the columns that we have. And if the columns says last name, that's the only
So
way.
we're not deciding what's the last name and what's the first name. It's whatever in the structured form that the patient may have filled out. Whatever they put in as their middle name is their middle name.
But also, if we have name and last name as a token, it doesn't matter what this data is going to be joined together, and it's going to be the same thing that in the other database if there is a match. All right. So then we did again completeness, distinctiveness, and we tried to see what we learned from this new organization. Of course, Social Security, when it is available, is the best match, is the most unique token. Also, well, the same thing, basically everything that is using the Social Security number is going to be perfect for the external data source, because we already know that Social Security is unique, nothing new there. Something kind of interesting here, maybe for you to think, is the number 8. The last 4 of the Social Security plus the birth date may not be the best way to match participants or people, which is also something that some combination that in some cases people use. So, well, that's also interesting to see here. What about our data? Well, again, when we have the Social Security number, the combination of all the combinations with Social Security number is going to be very high results. Of course, the combination of all the variables together is going to be the best results, but of course, also going to be the less number of results, because, well, we have very perfect.
Sorry, you mean the valid SSN numbers, or you consider all of the SSN numbers? That's for example,
No, it's valid SSN numbers. We don't tokenize
Oh, yeah,
unless
all of the
everything is
SSN is
valid.
valid.
only if it's complete and valid. The rest, we are just
It's
ignoring.
only 800,000 from 4.5 million patients, right, for the first line.
It's fascinating that you're 17 and 14 there, sort of the sound X. And then the last name and first initial and birth date. That's pretty complete.
Yeah. Something, I mean, I don't know if I'm going ahead, but of what I actually think, but I think this is not about what is the best combination in general for every scenario. It's about the process to get the best combination for your 2 data sets, the 2 data sets that you are going to analyze. So this is what's the result here, but can be totally different with 2 different data sets. So that's.
I have a question, like, moreover, so you have the SSN database which has all valid, correct SSN numbers, right?
Yes.
So just taking an intersection of the valid SSNs that are in the other database with whatever SSN is here in the SHC, shouldn't that give you the valid SSNs? It's just fun.
Should.
Just taking an intersection of which
So
ones are-
actually, the intersection is even smaller than, because you're assuming that everybody there are lots of people who are at SHC who may have a valid SSN, but actually not in the death data for Social Security, right?
I see. So that is missing in the death data in the SSN? Like the
Well,
SSN
it's
data?
not, so it's not, I think, so it's not just Social Security Administration. It's not a table we got from Social Security Administration for everybody who has a Social Security number.
see.
It's for people who have died.
I see. Okay, oh, that makes sense. Okay.
Okay, yeah, that makes sense. Yeah, got it. All right, so the next,
Sorry, and is the assumption that if you're not in the death, if you're not in the Social Security one, you're not dead? That's
And
the
you're not
assumption.
dead in our database, then we're gonna assume you're not.
so yeah, we cannot say it.
We have no reason to believe that you're dead.
All right. So, okay, so now we have the tokens, we have an idea, and we want to match them, but we want to do it using process. So what we did is we found how many people we have in our database with that data. And then we create tokens for, in this case, where it was 40,024. And from that selected group, we compare the tokens against the Social Security database. We only keep results when there's a unique match in both. So there's possible that same token can provide multiple matches in the Social Security Administration. We're not going to do with that right now. We just take the ones that will have 1-to-1 match. And then we evaluate and count the unique matches, the true positives, so how many are exactly the same date that we have in our system, or at least they're dead. And the false positives, which is well, the mismatches. And this is what we found. So when we have social security number, it's great. So if you have social security number, you can also play around with your variables and you will going to have a great results. But interesting to see token number 9, which is last name, middle name, first name, and birthday, just giving kind of very similar results to the first 3. So an open question is that, would that be a good way to match in this case these participants? Yes or no? And when and then we can go down and see how the percentage is going down. And of course, the individual variables are going to be the worst. Still, the token 8, social security, last 4, and birthday, it's not giving us very good matches. So just so. Yeah. So this is the process we did. This is what we were able to learn from our data. And basically what we have been trying to learn from researchers for people who is interested in this data, and we want your feedback. We want to know what you think about this. How do you think you will do it differently? Do you have an idea? Anything on how do you like to see the result of the data? What is in your perfect scenario? What would you want to see, knowing that it's kind of hard to have a perfect match all the time?
I had a question on the previous.
You want to go back?
Do you include like first, second, junior, senior in last name, like Thomas John the first? The
So
second?
remember, we took all of those out when we cleaned the data?
So then last name doesn't, so because I was thinking like you could have 3 generations of Thomas John.
So then you want something else to be
Right.
specifying, like separating it out.
Birthday,
So you go with birthday. That's why
Right.
just
As
last
long as
name,
the
just
other
first
things are okay.
name, yeah, are really. But I think what is really interesting in this is that, and this is to your point, like you were asking even about sort of the completeness of the Social Security LADMF data. We have 102 million records that we get from LADMF. We could only find 920 that we had. So those are 920 patients you can assume who died at Stanford Healthcare Hospital. So we know that data is accurate. Because remember, we're starting with the 40,000. What does the 40,000 mean? The 40,000 is the number of people for whom we have firsthand death data information available.
maybe they're recent. Are they recent deaths? Because
So, well, so this is data from 2008. So we're already looking at 12 years.
okay, so
Right.
not recent.
No, 14 years. So this kind of tells you that maybe not everybody who's even, what happened to the rest of the 39,000 who died at Stanford Healthcare? That information is obviously not in the Social Security Administration database, right? So neither data set is that complete.
Did you guys look and see who those people are? Are they foreigners? Are they?
No, yeah, we haven't done any of that. I mean, I think our goal was like, okay, let's stop here. Let's, show the community what we have, and then let's get feedback. We do have some more things that we kind of want to do. We also presented this to the Odyssey community, for those of you who are familiar with, OMOP. And, we did get some really good, one question, something that they suggest. There were two suggestions, I think, that were really useful that came out from that conversation. One was in the lines of what you were suggesting, which is, can you stratify it? Can you bin it in such a way to figure out out of that, even the 1,000 that do match, when do you have the most number of matches? As in, because the Social Security Administration keeps updating its data set, right? So is it true that maybe if you died this year, your data will actually be entered into the SSA 4 years from now? Is there some kind of a pattern, should we believe older data better or something like that? So that's one piece. And then the second piece that they were saying was if you looked at the way we tokenized, we used the actual dates or the death date right? We were seeing, does the death date match exactly? They were like instead of doing an exact match, can you go plus or minus 7 days for both? And then hopefully the matches will increase, but in general, people don't know the dates. Yeah.
And
So
how
so
confident
just-
are we in that? That enters in the probabilistic approach. So there's many things that we can just do with probability, like giving you, okay, we think that this is 99%, but is that good enough for your study? We don't know. So we want to learn from you. We want to hear from you and to know what could be the best next step in this process.
So the one other thing that I think, Álvaro, you may want to mention is what we have actually done in Stride.
Oh, sure. So I have to say thank you, or because
Could you clarify something for me? So you described a trade-off, right? Between how certain you are that this is a real person in the database and maybe they're not, right? Or if it's the same person, I'm not quite sure. What is you're doing this because you're talking about this because it has implications for downstream data analysis. Could you please outline what those implications might be? I mean, so if you have a slider, you can include fewer or more with more or less confidence. How would that affect some statistical analysis of the data that we do?
Yeah, I guess I just have one example in my head is some studies, you care about the fact of death. You don't really care about the date of the death. But for some other studies, the age of the participant at the death is very important.
Yeah.
So that can be one scenario, and we'll have to think about it. I don't know more.
You're primarily talking about how many people you have in your study, if you can match them or not, by confirming they're dead, right? So if you slide it to take a lot more, you have a lot more people in the study, but it all depends on how many of those people are bad or are not actual matches.
Exactly.
That totally blows up your study.
Correct.
So that's the principal goal of.
So I'll tell you what, for example, yeah, you want to go ahead and show the Stride slide?
All right, let me find that.
I think it's in our appendix.
Somewhere here.
And for me, for example, what I would want to know is I care about the survival of my people. So if I lose them because I want to know whether they're dead or not. And it'll make, I mean, I'm assuming if they're not dead, that they're alive, which might be a really stupid assumption.
Well, in principle, it's correct.
Well,
So one approach that is taken currently is to use Social Security date of birth or Social Security birth of year, first name and last name. But then this is going to, well, we just saw the whole process. This can give us a lot of false positives in some scenarios. So just to have that as a reference, it's not a simple match when you're doing this kind. Not even for, in this case, we're talking about data, but if you're just merging two databases with whatever group of people, you have to be careful about what is the best way to do it.
So if you kind of want to summarize, we're saying, okay, our EHR data, death data is sparse. How can we enrich it? So we say, okay, can we go to an external data source? So you look at the external data source that we have access to, that is the Social Security Administration data source. Currently in Stride, we are using two tokens, and the tokens are Social Security number plus date of birth, or Social Security number, name, and year of birth. So these are two tokens that we create. If the tokens match between the two data sets. So I'm not saying that the dates of, and we don't have the date of death in our database, then we bring in whatever Social Security is giving us. And with that, we can add about 156,000 new dates of death. But what a lot of Álvaro's analysis was doing was saying, we're assuming that, hey, if the tokens match, then the deaths must match. So we're saying, assume, let's look at that particular assumption. If the dates for the ones that we do have a date of death for both, let's subset that out. That's the 40,000 that we were studying in detail. Does that kind of make sense?
Does it always match exactly? Or are there errors?
Exactly, for the ones that we know we have both of.
Yeah,
And
they-
that's
do
what
they
we were
match-
showing that
match
it
on the
doesn't.
external and the SHC data set, like exactly do the
You saw that number, that's just 900. Out of 1,000 that, so 1,000 tokens match, only 900 dates of death.
Yeah, I got two questions. First, I'm really curious to understand what the differences is in between those people who have died at SHC that you can match with the SSN death database with that you cannot match, and see what might be the underlying differences. Maybe you'll find something really interesting that for a certain subgroup, it's very prevalent that you have a missing SSN. And the second thing is, are you doing the direct matching? Because I can imagine, let's say, somehow some person is able to bypass the filter that you have by missing one letter. And if you do the exact matching, last name, everything matches, but just because of that SSN number, you won't be able to match that. If you have found such cases, and if you have looked into
So that's something else that we've thought of doing, like saying if you, so like essentially you look at the distance in between the two social security numbers, because if it's just a number swap,
okay,
right, which is very common or possible. And the same thing could
Yeah.
happen with the date of death or date of birth as well, right?
okay,
So, yeah, so this is kind of going into the next level of
Yeah.
analysis.
There's also another approach is, okay, that can happen for one token, but that record match happened for more tokens. So did you get the same result with how many other tokens?
Mhm.
With maybe that variable wasn't present. If you
Yeah.
get it, if you get the match, maybe it is, maybe if you just get one match with one token and not and any other token in the list produce a match, so maybe that was a mistake. So
See.
it's also another way to explore this. I have a question here from the chat, which is, how can we make sure that the people who get results, for example, for token 7 is the same or not that the people who get results for token 9? And the answer is we don't know yet. We need to do that analysis too. We need to take those two groups and make sure what is the difference between them and see if it really is adding a lot of value in a lot of different people or not.
Is there a next step just to match it with the California data? That would be very interesting.
Yeah, once we get our handle on that, we haven't yet gotten the California death data. But you had asked an earlier question, like when is the data from the LADMF file? So it contains records from 1936 onwards. I think more than 102 million people have died since 1936.
And the hospital data is since when?
2008.
How much of this is a problem not in data, but in workflow? That providers may know of their patients dying, but are not incented to indicate so in the record.
Or to indicate it with the right information associated with that.
Yeah,
patient.
I
Their
mean-
motivation to do it.
Right, I mean, of those who are lost to follow-up, how many are dead? And how many are already in the system? And if only there were incentives to designate them as dead, would you solve some of this problem?
Yeah, I think that's the challenge. It's messy data, and I don't think there's going to be any way to fix that at that level, I guess, or it's hard, or to incentivize people to do the right thing and capture the right data in the right way.
That's an interesting question because there is no, if you're a healthy person being followed up at Stanford because you were sick and now you're well, and you have your yearly, your 1-year checkup after your surgery or whatever, then you're alive then, right? But there's no incentive for the care team to follow up on that individual next year.
They just lost a follow-up and that's it.
Are they alive or dead?
Yeah.
I guess with the California question, isn't the assumption that like everyone that would be in the California death database would already be accounted for in the SSA?
No, because there is an SSA that's the master, sort of a more accurate death data at the social security level, but that's not what we have access to. So the LADMF data set that we have access to does not include the data that the states provide up to the Social Security Administration.
So it's a lot of data, but it's not complete. It's just as we have right now.
But at the national level, the incentive to know whether you're alive or dead is really taxation. right? There's no,
Medicare, all sorts of things in this one.
well,
Yeah.
but that,
Paying out, coming in.
but it's really, it's with respect to funding, something. Right? I mean, there's no, at the lower levels, there's no reason to notify anybody that you're alive or dead.
Well, you may want to keep your spouse's check too, right? So you may not want to tell them that they died.
The hospital, though, has an obligation to report deaths to Social Security, does it not?
Hospital, I believe, yes.
I'm wondering about all those ones that I think you said there were a lot that died in the hospital that you can't find in the Social Security records. Doesn't that seem weird?
Yeah, I
That
don't
was a
know.
really large number.
That is a large number.
But are they going to the state and the state notifies?
That's exactly what I was gonna say.
Yeah.
Does it go to they probably have an obligation to notify the state. I don't know if they have an obligation to notify.
Yeah, it's probably state level, which would be nice. It would be nice to see how your data matches the California Death Index.
All these issues will go away once we're all required to have a biometric ID.
Yeah, big tick. I'm having. This was really interesting as a retrospective analysis, as it were. But an awful lot of it, I think, would be really informed by a practical analysis of the realistic things that happen to this data along its pipeline. So just taking the example of the Stanford reporting to somebody who reports to somebody. When my father passed away a year ago, it was, my father passed away and it was maybe a week before like everybody in the universe, except a few, had that information. It went very fast from, in that case, it was the police reporting it to whatever they report to whatever. And so my sense is that that part of the reporting system works very efficiently, and actually looking at the reporting processes explicitly and thinking about things like I'm thinking about last, middle, first combinations. And if you have a middle in one case and don't have it in the other, that makes it different. So you're dropping all of those, but I would expect a lot of those to be different. So that spending time analyzing the practicalities of some of these cases seems like it might be a lot more fruitful, and accommodating them in the algorithm seems like it might be more fruitful than trying to cut across a retrospective analysis of all 10,000 combinations that you're dealing with of what to do next, right? In terms of immediate return on investment of now we can match 30% more or something like that. Just a lot of good questions.
Yeah, no, I do have a question for I don't know how many of you have more experience with the probabilistics approach. You're researchers, so I assume you're familiar with that. You think that a probabilistic approach will produce better results if we go with statistics, if we go to machine learning? Is that something that
A good one will, quote unquote.
because that has its cons
So
too.
what is your precise task? What do you want to predict?
So I want to learn from you what is the best result for you, so you can use it.
So I meant if you built a probabilistic model, what would the inputs be and what would the outputs be?
Oh, the input will be the data that we have.
I'm not talking about learning, I'm talking about the performance, at the performance time. If you got this model, you learned it from the data. Now, you give it, what do you give it? And what does it predict?
Okay.
Until you define your task, we can't answer your question.
That's great, thank you.
I guess what we're really saying is that, hey, if we sort of loosen the parameters that we use for matching, do we get better matches for, say, those death dates, right? Like, that's
Sure.
really what we're saying, asking.
You're already doing that. So I'm not sure what the difference is. If you mean that you do edit distance or things like that, sure, you can do that. That's not especially probabilistic.
Right. No, edit, yeah, do edit distance, do even for the dates, allow
Yeah.
plus or minus.
I mean, you could build like probabilistic motifs or something, right? And try and do probabilistic matches with those. I mean, there's all sorts of things you could do, but don't make a big distinction here.
Yeah, and in the end, you have whatever you try to do, the only way you find out if it works is to test it against a known set of data. And
That, is not that good. So then the next question is, okay, suppose we do probabilistic matching. And, when we do these, when we loosen the parameters, we get you more dates of death, possible dates of death. How would you want this represented in the final data that's given to you? Like, these are the deaths we know of because they came from the Stanford EHR. These are the deaths we are assuming are right because the tokens between the Social Security and the Stanford data, the tokens matched, and we didn't have this data in the Stanford data.
Right.
This is, the name sounds, the token probabilistically matched, right? Because I mean, if I use SoundX.
Right. But you are talking about something that's inherently unsupervised, right? Because unless you have labeled data, which is exactly what you don't have, then you're not gonna be able to train a classifier for this. Right? So
I'd want a dial. Give me a dial. Need more deaths. Need more accuracy. Seriously.
Yeah, that's what it is.
Because that's exactly what the
It's true.
information
It
you
was the
have
way he said it.
is going to be balanced that way.
So let's kill more people.
So as a user, what do you want to see? Do you want to see those probabilistic?
Sometimes,
deaths?
yes, sometimes you want to see as many as you can because you can use your own analyses on them, or you can use other mechanisms that tell you if they're useful to have. In other cases, it's like, no, I need to be absolutely sure because any wrong death is going to screw up my whole analysis.
And then how do I use that scale?
You
that you-
pre-tested it against all the possible
Correct.
things, including your edit distances and everything else, and say, okay, the thing that gives us the most accuracy is this one at the top of the list. We'll just give them the ones that use that over.
I'll tell
That's
you
what
one
you were
place you should
thinking.
look to the literature for ideas is that there was a bunch of work on, there has been a bunch of work on database integration, right? You have multiple databases, and you want to automatically combine the results to build some federated databases. And the early work was like Mike Genesreth over in computer science, built a set of rules that would automatically do the mapping. But then other people came along and said, oh no, let's do statistical analyses, let's do string matching. Hector Garcia Molina did a bunch of this kind of stuff. And so there's a big literature on how to use statistical techniques to do database integration. And that will, and there will be ideas in there for you about other tools you can use to try to play your game. It's not the same game, but you may be able to use some of their subroutines. They were certainly doing things like string matching.
I like the dial.
It is.
The label is important. Don't forget the label. More deaths.
All right, we reached the end of the hour, so we really want to thank you.
Thank
You
you.
can stick around and give it some more.
All right.
Darn it, I just want to know who's dead, who's not dead.
I think of the coroner in the Wizard of Oz, since the witch is not merely dead, she's sincerely dead.
Yeah.
I don't remember that.
What?
I don't remember that.
Clearly, there must be some sort of gradation in terms of degree of certainty.
Definitely dead, definitely dead. Versus possibly dead, yeah.